they have a direction, and they obey the vector laws. We'll be studying these vector laws in detail. You have parallelogram law, you have triangle law, you have polygon law. So quantities like velocity, force, acceleration, throughout we were talking, no, velocity is a vector quantity. This is having a direction. Speed, remember speed, distance, these were all scalar quantities. Why? Because they had no direction. Nowhere we considered any direction. In velocity, remember, we had to apply a sign convention where minus sign was present, plus sign was present. So these quantities, we call them as vector quantities. When we talk about scalar, there is just a magnitude present of the quantity. You don't need to put it up for the particular quantity. You don't need to put up the direction. You don't need to use any vector laws. Just algebraically, this follows algebraic laws. Algebraic laws means you just have to algebraically add it or subtract it, divide it, multiply. The way normal mathematics you have been using, this is how you represent. Now coming to the point, what is meant by a vector quantity? Vector quantity means, see, suppose this is written F is equal to minus 2 Newton due east. Or let me remove this minus sign. Due east is already mentioned. So what is F? Force is a physical quantity. Force is a physical quantity. Equal to sign is a mathematical operation. Now see, ignoring whatever sign is present in front of you, whether it's plus present, whether it's minus present, I have no idea which sign is present. Yes, it could be plus, it could be minus. Suppose here, let's assume this is minus given, this is plus given, any sign can be put up. So when we talk about this, 2 Newton, just the number 2, only this number 2, except for the signs which are present, except for anything which is written. This is called the magnitude. This is called the magnitude. Now, what is Newton? Newton is the unit. This is the SI unit, in fact. And what is due east? Due east is the direction. Why? Because we are talking about only vectors now. So in your vectors, you will be having a magnitude. See, now you can see you are having a magnitude, direction, and for calculation of force, for solving force, you cannot add two forces directly. You have to follow all the laws that are present. Now, how to understand, how to identify whether a quantity that is written is a vector or scalar? So in your books, no, what you will see, an arrow is made. What is this arrow? This is basically having a head and a tail. So in this arrow, you will be able to figure this out. So a vector is present. Or some textbooks do what? Suppose force is written. So instead of putting the arrow, they just make the text bold. So sometimes this can also, you can witness in your textbook, but what you have to use is an arrow. Write the symbol, put an arrow, this will represent vector. Like if I just write this becomes speed. As soon as I put an arrow, this becomes velocity because of vector and scalar quantities like this. Let me tell you this. See, like v is equal to minus 4 meter per second. Velocity is what? Velocity is a physical quantity, right? Equal to sign is a mathematical operation. Negative sign is telling me the direction. Remember, in relative velocity, we used to have our final answer as minus or plus, and I used to tell you that whatever sign convention you have chosen, this is telling you that exact direction. So this is that. Now, since here it is written minus 4, but I'll ignore this minus sign. I'll just focus on this 4. Now only 4, whether it's plus 4, whether it's minus 4, I'm just concerned with the number 4. Number 4 is what? This is the magnitude. And meter per second, this is the SI unit. So vectors have magnitude plus direction plus the laws also. And scalar quantities just have the magnitude. This is what you have to remember. Fine. So now coming to the types of vectors, this I'll tell you. First, start writing from here. Written till here? See, Abdul, we have started with the vectors quantities. Right now, we have not gone into the details of it. This is just a brief of vectors that how to differentiate between vectors and scalars. So in vectors, you have the magnitude, direction, and the laws. So laws we'll study later. First, let us just study unit vectors, because unit vectors, we need this. You people have written? Hudeja, Shaista.
Yes, ma'am.
Done?
Completed, ma'am.
Now see the basic types of vectors which you have. These won't be used so much. We'll just quickly do it. We have to main study the unit vectors. See, equal vectors are there. Equal vectors means two vectors which are exact identical to each other. So you will call them as equal vectors. Negative vectors means which are opposite to each other. If this is v is equal to minus 4 meter per second, on one hand you will be having v is equal to 4 meter per second. Like this. Those are negative vectors. Then we have parallel vectors and anti-parallel vectors. Class, these two vectors are important. These terms will be used so much. Parallel vectors and anti-parallel vectors. Get your basics cleared here only. See, when two vectors are parallel, this means that both the angle between the vectors is 0 degree. It means both the head should point in the same direction and tail should be in one direction. Coming to the opposite one. See, coming to this opposite one. Here the head coincides with the tail and here the tail coincides with the head. That is, both are exactly opposite to each other. See, when you will keep them together, the angle that is made between them, you can overlap it. So angle is 0 degree. But when you keep both of them, the angle that is formed total, this is 180 degrees. So these are anti-parallel vectors. Whenever anti-parallel word will be mentioned, always remember that it is 180 degree which will be mentioned. And whenever parallel term will be mentioned, quickly understand that this is 0 vector. All right. Now starting with unit vectors, quickly note down this types of vectors, then let us start with unit vectors. See, let us now start with unit vectors. See, unit vectors are what? Vectors that have the magnitude 1. See, that's why I was telling you constantly, understand the term magnitude. This term will be repeated. Vectors that have the unit 1 as magnitude means just unit magnitude. Unit magnitude means 1 is the magnitude. Like if I give you force is equal to 1 Newton, 1 is the magnitude here. This means this is a unit vector. But every time no writing 1 Newton like this is not possible. So we have standardized universal vectors also. Fine. So unit vector is what? Unit vector is like, yes, see this. This is what? F cap. We put a sign cap to represent unit vector. You will be seeing I cap, J cap, K cap. So that will make it easier for you. So cap symbol, whenever you see, that means a vector. If only this is written, this means a complete vector. When this cap symbol is present, that means just a unit vector. Fine? Like this, you have to remember it. Now see class, how to make unit vectors. The formula how to make unit vectors, this is simple. This is not very lengthy. See, like this, velocity is 1 meter per second along x-axis. Now, how to make a unit vector? Every time in the question, you will not be given a unit vector completely. It's you who has to identify and who has to make it. Now class, 3 terms I am writing again. Whenever this is written, a vector with this arrow, this means this is the complete vector. When only cap is written, this means it's the unit vector. Unit means 1 only. When this is a vector, but with modulus is present on both the sides, moduli are present. This means we are just talking about the magnitude, be it -1 or +1. I'm just talking about the magnitude. Now, what is the formula of the unit vector? Unit vector A will be equal to, this is the unit vector A, this is equal to vector A divided by the magnitude of vector A. How to calculate the magnitude? This I will tell you. How to calculate the magnitude. This is also not very difficult. This is easy. This unit vectors portion no, from your vectors. This is easy. So what is this? This is unit vector. This is the complete vector. This is the magnitude of vector. This is the entire form. Now see, there are certain universal unit vectors which are present along the axis to represent the direction. See, these are all your axes which are present. For x-axis, we have the unit vector as I cap. Now, if it's positive x-axis, so that becomes plus I cap. If it's negative x-axis, that becomes minus I cap. For y-axis, we have j cap. J cap is the unit vector along y-axis. So for positive y-axis, we have plus j cap. For negative y-axis, we have minus j cap. Then k cap is used as the unit vector for z-axis. So for positive z-axis, we are having plus k cap. For negative z-axis, we are having minus k cap. So when I say plus j cap, you should immediately, it should come to your mind that I'm talking about positive y-axis. Minus I cap, negative x-axis. Minus k cap, negative z-axis. Fine, k cap, positive z-axis. Plus I cap, positive x-axis. Like this. All this should come to your mind. This should be at your tips because this will be used throughout. Throughout means vectors will be used throughout. See, vector quantities are so much. They are distributed in your syllabus. Not only in class 11th. In class 12th also you have vector quantities. So there you will be requiring all these. Let me start with Cartesian form. Before that, quickly write it down. Then I'll start with this Cartesian form. Here I'll tell you how to calculate the magnitude. First, write it down. Written class till here, universal unit vectors. Is this clear?
Yes, ma'am. Yes, ma'am.
Khadija? Abdul?
Yes, ma'am.
Yeah?
Yeah.
Okay, fine. Now let us see the actual calculation part. How do we actually write the vectors in Cartesian form? For example, I am writing force as 3 I cap plus 2 J cap plus 6 K cap. So what is this 3? What is this 2, 6? These are the coefficient of the unit vector. So that I have represented as A1, A2, A3. Fine. So 3 I cap plus 2 J cap plus 6 K cap, anything. This is just the component along x-axis. This means coefficient of x-axis. Coefficient of I cap, that is component along x-axis. A2 is what? Component along y-axis. That is coefficient of J cap. A3 is what? Component along z-axis. That is coefficient of K cap. Now, this is the formula which I was telling you how to calculate the magnitude of a vector. This is how you will calculate the magnitude of a vector. See, A cap is given as I cap minus 2J cap plus 3K cap. How do I have to write it? Under root A1 square plus A2 square plus A3 square. See, if I have to write the magnitude of this A, the magnitude will be A1 square. A1 was what? A1 was the coefficient of I cap. See, what is the coefficient of I cap over here? Only 1 is written. So that means 1 square plus. Now, what is the coefficient of J cap here? Minus 2. Minus 2 is the coefficient of J cap. Means apart from J cap, whatever is written, whether it's plus 2, minus 2, you will include plus, because this is not the magnitude. Magnitude we are calculating. So this will be minus 2 whole square plus. What is the coefficient of K cap? 3. 3 square. That is under root 1. Minus 2 into minus 2 will become 4 plus 9. That is root 40. So the answer is root 40. This is the final answer. See, write it down. I'll tell you later. We'll practice some more examples. Write it down. Now see, this is one more question. A vector is given as I cap minus j cap minus k cap. In the first part, we have to calculate the magnitude of A. In the second part, we have to form the unit vector. So for the magnitude of A, what have we discussed? If we have to find out the magnitude of any vector, we take the coefficient square and add it up. Yes? See, Abdul, what is the coefficient of I cap? In this, what is the coefficient of I cap?
Ma'am, 1.
1. Very good. So this becomes 1 square plus.
Minus plus
Yes, Abdul, what is the coefficient of j cap?
1.
Not 1. Look carefully.
Minus 1.
Minus 1. Very good. So that means minus 1 whole square. And this is also minus 1 whole square. So this becomes 1 plus 1 plus 1 under root, that is root 2. All right. Now the second part we have to form the unit vector. How did I tell you unit vector is formed? Take the vector as it is, divide by its magnitude. What is the vector? I cap minus j cap minus k cap. Divide by its magnitude. This is the unit vector. If you want, you can separate it. I cap by root 3 minus j cap by root 3 minus k cap by root 3 like this. Okay. Now we'll see this was just if one vector you have. If you are having more than a single vector, so how will you add them? How will you subtract them? Note this down, then we'll see addition and subtraction of vectors. This is clear to others also? Shaista?
Yes, ma'am.
Okay, good. See, when we have to add or subtract in Cartesian form, how do we do it? Suppose two vectors are given to you. A1 I cap plus A2 j cap plus A3 k cap. This is one vector. And then you have another vector which is B1 I cap plus B2 j cap plus B3 k cap. Fine. Now see, how do you add it? Just take the like coefficients and add it. If we are talking about I cap, so coefficient of I caps will be added. So A1 plus B1, A2 plus B2, A3 plus B3. And when we are subtracting, same thing, A1 minus B1, A2 minus B2, A3 minus B. Like this is written. See, let's just complete the example. Suppose E plus F, E vector plus F is there. So what we do? 3 plus 2 I cap. This plus this, that is 2 plus 9 j cap plus, what's the coefficient here? Minus 1 plus 3. So what are we left with? This is 5 I cap. This is 11 j cap. This is 2 k cap. This is your final answer. Similarly, when we are subtracting, this will become 3 minus 2 I cap plus this will become 2 minus 9 j cap plus this will become minus 1 minus 3 k cap. So what are we left with? 3 minus 2, 1. 1 I cap means I cap. You can write 1, you cannot write 1, both have the same. 7 minus 7 j cap minus 4 k cap. That's it. This is how you have to add them, subtract them. One more question based on this we'll see. First write it down. Addition and subtraction in Cartesian form. See, one vector that is given to us is a cap, which is 3 I cap plus 6 j cap minus 2k cap, and b is 0 I cap minus 4j cap plus 3k cap. So we have to add both the vectors, right? And then we have to find out, see, actually we have to find out magnitude of resultant C. But how will we find out magnitude if we do not know what are the coefficients of I cap, j cap, k cap in C vector, right? So first what we'll do, we'll find out the vector C first. Once we have the vector C, we'll be able to find out its magnitude. All right. Yes, Khadija. Khadija, you tell me the procedure after it. See, what should be added? Coefficients get added?
Yeah.
Yes. So it should be coefficients of I cap
3 plus 0.
3 plus
0.
0. Very good. Very good, Khadija. Plus, Khadija, this one also. What about j cap?
6 plus 4 j cap
Is it plus 4?
minus
Yes. So it is actually 6 plus, but this becomes minus 4.
minus.
We'll write this as 6 minus 4 because of the coefficient 6 minus 4. Khadija, complete this only. If this is k cap, then
2 minus 2 plus 3 k cap.
very good. Very good. So what is our C vector at the last? We have 3I cap. This is plus 2j cap. This is plus 2j cap. This is 3 minus 2. That is 1 k cap. Now we have the vector with us. The complete vector is with us. See, if this is the vector, now we have to find its magnitude because this is not the answer to our question, right? Magnitude of resultant of vector C we have to find. See, for the magnitude, coefficients and then squaring the coefficients and adding them. Khudeja, what should I write now? Yes, Khudeja?
3 square
3 square. Very good. Next, Khudeja. Then
plus 2 square
plus 2 square plus
plus 1.
1. Very good. So this becomes 9 plus 4 plus 1. That is root 14. So root 14 is the magnitude of the vector. Write it down. One last question based on subtraction we'll do, but that you all will answer me in the chat column quickly. Note this down first. Yes, send me the solutions of this. Not the solution, the complete answer. Just R. Just tell me R. Don't tell me the magnitude. Just the vector R. All of you, quickly. Yes, this time was sufficient. Yes, Mariam, your answer. Mariam, Abdul, where are your
Yes,
answers?
ma'am.
You have not sent your answers in the chat column. Okay, Shaista has sent. Only Shaista has sent. So Khudeja, Khadija, Abdul, Mariam, where are your answers? This time was
I'm
sufficient.
sending.
See, when we are solving this, we are just subtracting both the vectors. So when we are writing h vector minus I vector gives you a resultant, you are subtracting the coefficients 2 minus 3 I cap plus minus 2 minus 4 j cap plus minus 1 plus 0 k cap. So this becomes 2 plus 3, that is 5 I cap plus minus 6 j cap, or directly I'm writing this as minus 6. So this becomes 5 I cap minus 6 j cap minus j cap. That's the answer. What Shaista wrote? 5 I cap minus j cap minus 1 j cap. Very good, Shaista. The answer is correct. Note this down quickly. Class, you people are having an extra class on Wednesday. And now the duration of your batch will be 2 hours, 1.5 hours. No, I take the class at 8 p.m. Your class terminates. So now 8:30, 2 hours proper class you will have on a Wednesday, 6:30 IST means the same timing. You will be having one more extra class. So the class will increase 2 days plus one extra class. Because your syllabus is lagging behind, we are just on vector, so we have to rush up with the syllabus. At least this much we should be able to cover, so that you are at least able to pass in your exams. You are able to attempt your half yearly exams also well. So for that, we have to take extra classes also. For that, we have to have larger values of the number of days which we are having. So extra class on Wednesday, 6:30, that is tomorrow, and 2 hours class duration from the next class. Not today, but from the next class. So please arrange accordingly. Accordingly to this schedule, please arrange the rest of the matter. Written till here?
Yes, ma'am.
Done? Okay. Now see, that completes with unit vectors. Unit vectors you will be having throughout. So unit vectors you have to study. These are the basics. Now the portion that I left, that was parallelogram. See, vectors are actually divided into two groups. One you have the polar form, other you have the Cartesian form. So Cartesian form we have studied. Cartesian form is the I cap, J cap, K cap. This is the Cartesian form. In polar form, we talk about the angle. We talk about angle, theta, two vectors are there. So Cartesian form is over. This is over. Let's start with polar form. Now, when we have to add two vectors in polar form means, again, when you are able to identify an angle between the two vectors, that is polar form. So you have three laws: parallelogram law, triangle law, polygon law. Out of this, parallelogram law is very, very important. Triangle law we'll be studying. It is similar to parallelogram law. Polygon law is also similar to parallelogram law. The final resultant of all these is same. The same formula you have to remember. But the derivation of parallelogram law can come in your exam. All right. See, parallelogram law of vector addition. The criteria that we have is that it can add only two vectors at a time. Suppose V1 is there, V2 is there. Suppose V1 is there, V2 is there, and V3 is there. So parallelogram law cannot add more than two vectors. V1, V2 are there. So it will first add them. It will have its resultant first. See, resultant will be there. Then this resultant and this resultant, they will be calculated, and finally a final resultant as the answer will be obtained. Understood? If you are having three vectors, four vectors, all of them are located in different directions, then you won't be able to solve using single parallelogram. You have to break up in two parts, two vectors at a time. Then further one more vector will get added. Then further one more vector, further one more vector. Like this, you have to solve all the vectors. Nextly, vectors should have same starting point. Now, vectors should have same starting point means for parallelogram, they have to be co-initial. Co-initial means their tails should coincide. Co-initial vectors means tails should coincide. This means what? This is one vector, let's say A. Like this. See, two vectors can have a certain separation. And when you are extending them, then also they can form an angle, but this is not applicable because their tails are not coinciding, so they are not co-initial vectors. This case with the angle between them, A vector and B vector. This is what is meant by co-initial vector. Now, when we talk about parallelogram, for parallelogram, you have to understand the parallelogram itself. What are the basic properties? The opposite sides are equal. This side is equal to this side. This opposite side is equal to this opposite side. And similarly, opposite angles are also equal. If this angle is something with this value, it will be equal to this value. And both of these angles are equal. And one property that you have, if I cut all the angles, no, I'll get a complete circle that is 360 degrees. So what you have to remember that sum of all the angles that are present within the parallelogram, the sum is 360 degrees. Law, I'll tell you later. First, just write down all these points before starting with it. This class, all those who have completed, see, tomorrow we'll continue the same. So now, please, again, I'm repeating this. Wednesday, you people will be having classes same timing. So Tuesday, Wednesday, Thursday. All right. And now the class duration will be of 2 hours because we have to complete some portions before your final exams begin. All right. So if you people have completed, you can start leaving one by one. Thank you so much. We'll continue this in the next class.
Ma'am, could you repeat? I couldn't understand.
Abdul, you're saying something?
Yes, ma'am. Ma'am, could you repeat the timing?
See, same timing, 6:30 p.m. IST you are having, no? Today. Same
Yes, ma'am.
timings on Wednesday as well. Okay.
Okay. Ma'am, is there assessment?
Yes, Abdul?
Is there the after class assessment today?
Yes. After class assessment
Okay.
today, please attempt it. Okay. Based on unit vectors only.